Hello, allow me to present an overview of Advanced Cooling and Refrigeration Technologies Development, Annex 53. My name is Reinhard Rademacher from the University of Maryland, and together with Van Baxter of Oak Ridge National Laboratory, we are cooperating agents for this annex. What are the drivers for Annex 53? The IEA has determined that in OECD countries, by 2050, the energy consumption for comfort cooling will have increased by over 50%. And in non-OECD countries, that increase will be fourfold. And this is not accounting for energy consumption for refrigeration requirements for food preservation, which of course is crucial for supporting a growing population. So what's to be done? The objective of Annex 53 is to advance technical development of cooling and refrigeration systems to minimize energy consumption and global warming impact. We are taking a two-pronged approach: enhancement of conventional methods and development of emerging technologies. Enhancement of conventional methods does not really imply so much conventional enhancements, but they support vapor compression and absorption technology. One example here is using fuel cell membranes to pump water molecules from one airstream into a second airstream, essentially dehumidifying the first. A competing technology with this is using membranes again, but this time as a filter that filter water molecules out of a given airstream, supported by a vacuum that sucks the water vapor away. This humidification process can be pushed to a degree that the air is dried way more than desirable, and it allows us to spray small amount of water vapor in the air that results in cooling, but still dry airstream. So it could be a replacement for air conditioning technology, for traditional air conditioning technology entirely. A further project focuses on two-stage vapor compression system, but uses zeotropic refrigerant mixtures and manipulating the fractionation of the mixture such that for given operating conditions, the evaporator pressure is as high as it possibly be, higher than with traditional fluids, reducing the pressure ratio across the compressor and increasing energy efficiency. The pressure exchanger is a development that comes from the desalination industry, but has the capability of reducing the energy content and pressure of a high-pressure single-phase fluid and using that energy, this work recovery, to pre-compress a second single-phase stream. This would be the ideal replacement for an expansion valve in a CO2 cooling system or refrigeration system, increasing energy efficiency through work recovery. And the final highlight here for enhancement of conventional system shows what looks like a conventional adsorption system, but the research focuses on enhanced working fluids and the use of low-cost and highly effective polymer heat exchangers. Now, let's take a look at emerging technologies, and these are really substitutes for traditional technology. One of them is magnetocaloric cooling, which is under development for 4 decades or so and reaches certain levels of maturity. And this example here focuses on increasing the operating frequency of such systems. The tip of a magnet is rotating past a series of chambers that contain porous magnetocaloric material, creating pulses of heat, and these result into subsequent pulses or puffs of vapor that migrate from one chamber to the next, increasing the temperature level and therefore pumping heat. A second technology is elastocaloric cooling, which is relatively new with research of about a decade underway. The original concept under further development uses nickel titanium tubes as refrigerant, so there's no global warming potential here. Other researchers in the annex use nickel titanium sheet, and the last project employs elastocaloric technology to use waste heat. So it's an elastocaloric actuator using waste heat to operate an elastocaloric heat pump. So with these highlights in mind, and hopefully it triggers your interest in the technology, you find more information on our website under heatpumpingtechnologies.org/Annex53, or please contact Van Baxter or myself. And with this, thank you very much for your interest.